Hi, I'm GUO CHENG GUANG, 12 years old, Primary 6 from YUMIN Primary School. For this lesson, we are still at ordinary differential equations. Now for this ordinary differential equations, we have different methods to use. But for these different methods to use, we are going to learn how to use and when to use these methods by exemplification. And by exemplification, it's like using many examples to show us how to help us solve these problems, okay? So let's take a look at what type of example we have for this lesson. Now for this lesson, over here we have y, first derivative, plus 4x squared y over 3 bracket 1 minus x to the power of 4. Then here is e to the power of 2 inverse tangent x. Then y to the power of negative 2. And over here, one condition for x. X cannot be 1. Because over here, if it is equal to 1, then the denominator will be 0. Then this whole thing infinity. So we don't want that kind of case. But first of all, for this question, let's first analyze it. What type of example is this? What type of ordinary differential equation? So for this type of ordinary differential equation, first part here, this is the first order. Power of 4 and square. That means this part is non-linear. Then this is not equal to 0. That means this is non-homogeneous. And for this type of ordinary differential equations, we do have a name for it. For this type of ordinary differential equations, we call it the Bernoulli equations. Okay, the Bernoulli equations. So what is its general form like? What type of equation we can call the Bernoulli equations? So for this part, y first derivative plus px. Px here is a function of x. Then this function of x times y. And this is qx, another function of x times y to the power of n. And y to the power of n is just, well, y to the power of something. But for this type of equations, how can we solve it? We have to let u was just like a function. We let u be y to the power of 1 minus n. This part. So let's try over here. Can we straight away use it? Well, yes, because let's try to find it. So first part y prime here. This part px times y. Okay, here's a y already. Then this part is just px. Then here qx times y to the power of n, y to the power of n, qx. So we've got it. Then this part, let's let u be y to the power of. So it's 1 minus negative 2. So that means 1 plus 2, and that is 3. Then after that is to find what is y. So this would be u to the power of 1/3. Then after that, we still need to find the first derivative of y. Like this. Okay, so we have found these. So the next part is just to stuff all of these inside. So it is like this. After that, we can remove this part and this part at the same time. So just times u to the power of negative 2 over 3 on both sides. Then you can also times 3 on both sides. Like this. After that, what did you realize from here? Well, it seems similar to one of those types of examples we have done before. For this type of, until this step, we're going to use the IF, integrating factor. So it is e to the power of something integration. Now for that part is here. Like this. After that, what happens? So let's see. But this part, we might need to separate them. Okay, so that means we're going to use partial fractions. So let's first factorize this denominator. Okay, one part is 1 plus x squared. 1 plus x squared, it times 1 minus x squared to get this. But 1 minus x squared, you can continue factorizing. Like this. That means a, okay, so for example, we put this in the first part. That means you have ax plus b. And this would over 1 plus x squared. Now that plus c over 1 plus x. Then plus d over 1 minus x. Okay, so get these. And this part at last is just 4x squared. So let's find for the constants. Okay, this C stands for constants. Constant terms. For example, here is a B. Then here you have a C, which A here obviously don't have. And then you have D. Constant here, do we have any? No, we don't have. So that means B plus C plus D is a 0. Then X. X. How many X do we have here? Here you have 1A. Now B, do we have any x? Well, I don't think B we have any. No, we don't have any. Then C here, this is a negative C. Then over here is plus D. And this still we get a 0. Then is x squared. Now x squared, this part, let's find what can we have. Okay, so A we don't have, then B. Here you have a negative B, then here is a C, then here is a D. And this we get 4. Okay. Then you have x cubed. X cubed. Here you have a negative A. Here you have a negative C. Here is a D. Wait, looking at these two, A and negative A, well, it doesn't have an effect on this result. So that will tell us most probably A is 0. Okay, so these two will tell us A is 0. Next is B. Well, B, I think that will be easy. Just take this part, this constant, minus here. Then you get 2B. And 2B, this, be careful, this is minus 4. You get negative 4. So B would be a negative 2. Okay, now you have this. Then C. So let's see. From this part, C plus D. If you already saw this inside, so here negative 2, right? Oh, wait a second. A is a 0 here. D minus C is 0. What does that tell us? This tells us that C and D are equal. But from this part, we can get it 2 first. That means they're both 1. Okay, now we've got this. So that means you get these 3 parts. And that means here. But then you still have to integrate them. Now integrating them. Then at this part, what can we continue to have? Integration. First here, what is the integration on this part? Well, this is obviously an inverse tangent. This part obviously is ln. This part is also obviously ln. But we don't need a constant because this IF are going to times on both sides. And if you add that constant, then the constant from here will just simplify. Then from here we can make little changes. For example, this ln, we can take it down here. Well, ln inside this, we first can change it into a fraction. So get like this. Then after that, times it on both sides. Okay, so from this part, 3 you only get 3 times here. Now it is because that these two, they will just cancel out. Okay. Now for this part, what do we have? Okay, we can use the total differentiation. Now from this total differentiation, it would be, okay, so we got one part from here and here. Here for the first part. But here, we might want to have like a little bit of partial fraction later on. So from here, we can integrate at the same time. This part integration. Well, first part is just like this, then the second part, 3 times here. We want to try to factorize this. If it's just 1 minus, 1 plus, but no, that one would have 2x over 1 minus x. How about trying it another way? Because we don't want to have this ever again, it can make things very, very difficult for us. So if this is a minus 1, that is minus this 1 minus 1, 1 minus x over 1 minus x. Okay, so let me just write this more clearer. So that means it would become like this. Or this is just trying to factorize them. Like sometimes you have to try around with this. Okay, then from here, both sides will also need to integrate. But wait, since you integrate this part already, you have this extra arbitrary constant. Then after that, this, I think you'll most probably just write it as a C, since you have already found all of these. Then here you get back your y cubed. then that would mean you have to divide this part to the other side. So for y cubed, you took out this thing. Then for y, it means you'll have this whole thing to the power of 1 over 3. Okay, that means you get something like this. But which part would be more simpler? Let's see. For this part, you have to differentiate both sides during the verification. Differentiate both sides, okay. You also have to differentiate both sides, but just look at this part when you differentiate. Just by looking at this, you can already think, well, it's going to be very, very complicated. Why not choose a simpler one? Whereas this simple, this one is just a little bit of the product rule. Okay. So I guess I'll erase this part. So for this part, we will verify. Now this verification, we're going to use this part. So let's both sides differentiate. So this part. Now we can first differentiate this front part. Now this front part. Then after that, from this negative x, another negative. So I think we can close up this gap. Then after that, you can differentiate this part as 1 minus x. Then after that, for this 1 plus x, Then after that is this final part. Okay, like this. After that, I think we could try to make some changes here. What kind of changes can we make? Okay, let's just try as much as we can. This first part, now this 1 over x, and this part, why not we times this 1 minus x inside? Well, we can try. If we times 1 minus x inside, then we get 3 plus 3x. Well, just simplify with this. Okay, first part we can put it like this, then minus this part at the back. What kind of changes can we make? Now, in order to change back into this form, we are just missing this, right? What if we did change back? It's going to become like this. Then how about here? Okay, also change it back. Then at this part, this, we do have our y cubed. Now how does this help us in this process? Let me just tell you, this is going to be a little bit of magic. Okay, so-called magic. What if we just, these last 3 parts, at first you might not see why am I doing this. But let me just tell you, first these 3 parts common denominator. Just try first. So that means here is 1 minus x, here is 1 plus x, here is 1 plus x squared. And that means at last it will be 1 minus x to the power of 4. Now here what do you need? Here you need 1 plus x times 1 plus x squared. Now this part you need 1 minus x. Okay. So that means, okay, so let's make a calculation because here we do not have much space. 1 x squared and x cubed. Next, for this part, we'll have these 2 times together. So you get something like this. Therefore, this part, we have these 2 times together. Okay, so what do we get here? Wait, here you have 2. Wait, let's check. 1, 1. So here minus 2, so that means you don't have this. X. cancel out. Okay, x squared also cancel out. Wait, but then x cubed. Wait a second, there's one little part we didn't realize. Okay, this you also have to be careful. So let's just put all these in first. Wait, because here we use minus. Well, here we use minus, so yes, these are also minus. But wait, negative, negative. Okay, so I guess this is right. Yep, just now I was just making the final checking to make sure that after that no more mistakes. Okay, this is what we get. And now at this part we actually can finish, but it might look some sort of not similar to this. Well, if you want to make it similar, you also can. Y prime. So here, this part divide to the other side. At the same time, this you can move. It's just that this changes to positive. Y cubed divided by this. Y. Then here, okay, yes, you get it. So that means up here. Like this. Yep. Then after that, divided by this 3. So 3 brackets 1 minus x to the power of 4. Then after that, here you have the other parts. So that means y to the power of negative 2, then this 3 will be simplified. Okay, then like this. And we're done. Okay, so yeah, we're done. So right now for this part, I think we can end here. So if you like our videos, don't forget to subscribe to our channel. Thank you for your watching.